get the Dash community call for the 17th of January and our 97th meeting. And so although it was a little bit late, I did send out some notes last night, and I've combined the behavioral model and the regular notes. So that was an email last night, but basically we covered what we talked about last week in community and then behavioral model here. And then we thought maybe we had mentioned we'd talk about SCI header generator updates this week. So I was hoping to do that. And then also wanted to check the queue for PRs, etc. And if anyone has one they want to bring up, put it in the chat window or let me know and I can display. So did anyone have one specifically that they wanted to bring up today first? I'm going to take that as a no. So here are the lists of PRs. And I think we needed maybe one brief mention of the Fastpath design. Riff, you're here. So did you have one more thing you wanted to talk about here on Fastpath?
Yeah, I think Fastpath we like presented last week. So all the APIs are there. I think the only change we probably need to do is to switch the counters from the counter IDs to stats. So that is pretty much the only comment. So if there is no comment, like no more comment, I'll make some changes to change it to the stats. Then we can see if we can get the doc merged in, because there is no other content, I believe.
Okay. Does everyone else kind of agree with this or have comments about changing the counter ID? And I don't know if Marian's on the call. Let me check real quick here.
Yes, I am.
Marian, yeah, hey, did you happen to see this? Concerns about collecting info on a port level?
Riff, why should it be on the port level? Is it a global counter or?
Yeah, it's like a global counter for platform to check how things goes.
Okay, let me take a look at this API. I'm not sure if port would be the right place. Theoretically, you could have more than one. It's not really global.
Yeah, it is like not really global, but it's just like per port. We also can do it on the switch level, but I think I chatted with Prince. Usually, switch is not the place we add this type of stats. So I switched from switch to port.
But neither is port. Port is a physical entity.
I see. So then let's see what would be the best place. Yeah, we can discuss.
Over email?
Yeah, we can discuss it like offline or through the comment or yeah.
Okay. And okay, Prince. Okay, sounds good. Thank you, Riff. Awesome. And so did we want to pick up this week and talk about the SCI header generator that we talked about last week?
Yeah, that sounds good to me. Yeah, if there's no other topics.
Yeah, sure. Let's do.
Yeah.
Last call for any other topics, guys, before we talk about this. Okay. Yeah, let's go.
Okay. So, okay. So recently we made some changes to the Dash SCI like headers and lib SCI generator. So And to quickly capture all the changes and the latest stats, I actually made a small slides. So hopefully they will help. I'm going to, if you don't mind, I'm going to share the slides. Okay, thank you. And then let's see if I can do this one. Right? Then possible. Okay. Yeah. Can you all see my the screen? Okay, perfect. So all right. So this is site generation. The recent improvements I did. So to help like the generating the site header files and libsci points to the BME2 implementation. So basically here is where the site generator is, and this is the URL. Oh, oops, sorry, my bad. Oh, okay, yeah, this will be better. So this is the URL. So this is basically the Python file that here it reads the JSON and JSON-RT, and then generates the site header files and the libsci, so we can actually call. So this is what where it is in our the high-level workflow. All right. So the the motivation is that we actually are, as we are adding features, when we will need to do some changes to, support those new features, and then through that effort, we found several like the I won't say like a problem, but it's more like things we could improve along the line. So I just did it when I was doing the feature works. So the motivation would be first one is readability. So readability is that first of all is everything is like dictionary based. So basically, if I just take a screenshot of this the previous code. So everything is a dictionary based. So if you are not super familiar with P4 runtime like data structure, like how the JSON file looks like, it probably will be really hard to actually consume the code. So just by reading through it. So what I did at that time is basically I have a P4 runtime that is generated like JSON file generated, and the code side by side to see what actually it means. So that is the readability. So this is the first one. The second one is that the code is trying to be smart, but it's like vaguely smart. So so first of all, it has all these like namings. For example, like the name annotation. So you can see it's fairly hard to understand because like for example, why we need the first one, and also it's inconsistent. Sometimes it's a pipe, sometimes it's a column. So which one actually means which one and used in which place is not like too sure. So another thing is the type deduction. For example, every single field we have here, we actually need to generate like what type it is based on the the information we have in the P4 code. So one of the main factor we are using is actually the names. So say we have a metadata, and then sorry, not a metadata. I mean the table keys or action parameters or whatever. So what we are doing is that we use the name. Say okay, the name, if the name actually has IP, then it should be IP address. But then you see some people use the address instead of IP. Then it's like, oh, if it's the address, then let's do this one. And what if my address is the MAC address? Then let's do this, that. So it is like very flaky to do it this way. So yeah, that's one of the things. Another thing is also because it's trying to generate the header files through the code, and then but it doesn't really leverage some of the information. For example, here we have a metering bucket as an example, and then you see like here we have the metering counter. inbound and outbound. It has a byte counter. We're actually using those byte counters underneath. However, we actually have two fields here to say, okay, these are the metering counters. You can see it's almost exactly the same thing. And why it's like this is because we don't have a way to correlate the counters to the action. So instead of correctly generating the attribute, instead of like creating the connection, we say, okay, how about let's just add the two fake attributes that we will actually never use. So you see like read only is true. So you actually never set, and this is like really just read only from the SciAPI level, and then so you use this one to make the Sci header files work. So it's really tricky. This is also, you know, when it also makes some make the Sci like leap generator, generated leap Sci also like being interesting because the leap Sci or the BMV2 will expect these two fields getting set because it doesn't know like this is read only is actually never set, but on the API level, like Sci API level, this tool doesn't really can be set. So you see like on the leap side we generated, we actually set those parameters, but on the Sci API, it will actually never gets called. So it's a data code in the leap side, it's a data code in P4, and if you call an API, it just simply doesn't work. It will crash because P4 will say, I have no idea what it is. It seems like it's missing parameters. So this is one of the things like the problem like exists in the current implementation. And the last motivation is actually we actually have some issues when we updates current code. I'll take one of the example. I'm not just saying I'm not saying like this code is bad. It's just like it is what it is based on the you know the previous like toolchain we provided. It's not a it is unavoidable. So what happens is that when we generate the attribute, we actually take the attribute from the table keys and the parameters. And then whoever adds any table key or any parameter, those things can be merged. So you could merge from multiple actions, could merge from both table keys and parameters. And then those attributes are generated in whichever way it defines, or whichever way it fetches from the P4 runtime. So then what happens is that any attribute it generates, it could be generated in the middle. And that is not a very good practice in defining the Sci API, because you can see whenever the attributes gets generated in the middle, it breaks the API. So it doesn't have API compatibility, and this is something we could improve. Says, okay, what if we generate a new one? If we can have them to put in the end, that would be awesome. So this is, you know, the breaking changes on updates. Also, the last one would be some features are currently like or previously missing. For example, like a range match, list match, they don't actually support it. So in the end, we actually generated a different code from the what we want in the Sci or what is already checked in the Sci. Oh yeah.
One question, I didn't understand the sub bullet number 2. What exactly? Yeah. What does that mean?
Yeah. So let's say if a table, if a P4 table, if a P4 table has a parameter or annotation says that the table is object. So what happens is that table, when creating the when generating the Sci API, then Sci API will be generated with a table key and the action parameter. They both will be the attribute of the object of the Sci object.
Yeah.
So yeah. So if we change the key, or we add any like action parameter because of some new features or whatever, and then what happens is when we generate the attribute list, right? We will take the table keys, put it in the list. We'll take the action parameters, put it in the list. Let's say we added a new table key. Then the table key will be put before all the action parameters. that means that a new attribute will be generated in the middle of the existing attribute. And yeah, so that's what it actually means. Also, if a table
so it's just about the diff in the Sci API, like it's in the middle of the list.
Right.
Ah,
so
okay,
you can see previously, let's say this one is 1, right? VNet ID is 1, and then this policy ID is 2, right? So now the 2 is here instead of here. Like this one becomes 5. So,
so it's about binary compatibility.
Exactly. It's API compatibility. Yes. And the last one would be just like the range match, list match. They don't support. So in the end, when we generate the code, those attributes are generated like the with a incorrect type, then it doesn't match with whatever we want or whatever we checked in the Sci repo. So those are the key motivations. So that's what I found when I was doing the the new feature works, and so I just did a few changes that can somehow improve where we at. So the goals would be better readability and being explicit using annotation, just like it does what we want, or we do it in a smart way, but we are certain about what we're doing. Another thing is that, okay, we can provide some tools to ensure the API compatibility. Any new fields we add, we actually have a way to say, please add in the end, no matter where we actually define it. And then the last one would be just like ensures the generated code can match what we actually want or have in the Sci repo. So we don't have to always have the diff, because when we make the Sci headers, we always have a difference between the generated Sci and the Sci header files, and those differences needs to be ignored like manually. It's very annoying. So those are the goals. So then let's talk about like every single bullet and see how this problem gets solved. All right. So let's start from the readability. The readability is that first of all, instead of like using all the dictionaries, we say, how about we create really create like classes, like types. So instead of like doing the dictionary, let's create a class for every single element we create, and with a very clear hierarchy. So after parsing, it will be parsed like this. The top level will be Sci extensions. Then under the Sci, it could be like enum, and the enum will be enum member. Then every single one will be a Sci API set, because one API could have a set of listed tables, then has a different like objects like and correlated API like functions. So the sets will contain the table data, and each table contains a key and action. Action contains action parameter. We use this one to actually generate the Sci, like the final Sci header files and the lib Sci. So every single one of it is a class, and actually has like all the like fields like related fields like defined in it. So we know exactly what we are parsing, and So, and I'll take one of the example is that this is a table key, so we can see like the self is here, and when we do the parse, we actually provides what we are parsing like example people run the table, so we don't have to do the side-by-side thing, and what we are looking for is literally in the code. We just look at it as you save the effort. The last one would be like type hinting, because the type hinting is I won't say a new feature, but is added in the recent years in the Python. And so with the type hinting, we can actually enable a few things. First of all, it's a type, so we know what we're doing. The second thing is that it actually helps in intelligence, like to do the code completion. So when we are actually write code, it actually knows, okay, what types we have, what types we are looking at, what fields it has. So it actually, auto completes the code in a better way. So it saves the coding effort. Then the second one is that being this one is being vaguely smart. So it's trying to be explicit or smart with certainty. So what does this mean? Is that okay, first of all, we can improve our annotation. So this is a link to the annotation. If anyone is interested in, feel free to look at it. We actually add a list of annotations that supports all the different features. I'll send the link to the chat, so anyone everyone can click and look at it. So what does it what does it do is that instead of I'll take the let's say it goes here. Instead of using the names, we say, okay, this is a value, and the value has a type, and this type actually can be removed because we can deduct it from the type. It's a 64 bits, so yeah, it's using the 64. That makes sense. This is explicit annotations, and then besides annotation, we say, all right, how about the type handling? We don't want the using the names like the certain strings as an indicator in the variable names is probably not that stable. So we simplify the type handling. Then we actually added a type solver and all these type infos. For example, which type actually has which type of default value. So those things are previously dynamically set in the template. When we generate those templates, we say, oh, this is the ID. Then if it is ID, then please do the default says this, something like this. So it makes the template really hard to read. In fact, we can just put it in as a type info, because every single type, if it is different, then the default value would be we won't be having a one type that have two different types of the default parameters. If it is int 0, or if it's explicit set to 1, sure, then it's 1. But it won't be like if it's int, then the default parameter would be say no object ID, something like this. So it doesn't really work. So that's why all this info can be embedded in the type info. Then we can use this type info to generate the code instead of complicating our templates. So this is the second one. The third one is that being smart with the certainty is that, okay, let's take the counters as an example. So instead of having those counters here, let's say instead of having the counters here, those counters need to be generated to a certain table that is metering bucket. So as long as those counters being used, we can actually correlate those relationships. If the counter is called inside of action, then we know this counter will be used by this table. So, but where we can get those information? So there are two places we can get the information. The first place is, of course, the BMV2 code. The second place is actually the P4IR. So I look at the P4 or the P4 backend implementations. What I found is that the BMV2 will have its own the data structure, which is basically used for the BMV2 the program to consume. However, it's not generically applicable to any other things. For example, we are also looking at PNA. We're also looking at, say, DBTK or P4TC. So those things they don't recognize the BMV2 format. However, if we use the P4 IR, then we can actually have a very generic solution that applies to any backend, literally all the backends. Every backend also support a way to dump the IR after the optimization. So it's a almost standard way to write the P4 backend. So we can use the IR. So no matter which platform we are looking at, which backend we are looking at, which architecture we're looking at, which backend we are looking at, this approach will always work. So we basically use the P4IR to create the variable and action relationship or the table relationship in the code. For example, in here, if we know the counters gets called by this action, then the counters will be generated as attribute inside of those tables. So this is what I mean by smart with certainty. We know it is related, so it is related, instead of guessing from the name. All right. So this is this one, and then next one would be tools to ensure the API compatibility. So for this one, the solution is actually simple. What we did is added the order annotation here, so it actually has order equals 1. This one will be, I'll take this one as an example. Of course, we also have another one, say the ENI. So the ENI would be a even better example in this case, but it's the same thing. So in here, we actually have a metering policy, metering rules, and we also have another one is metering bucket or something. So they all generated in the same file. Then we can use the order to specify like which one you want to be the first. And because order is here, then if there is a new one gets added, then the new one will be generated in a certain order. And then if then messed up with the order, then we can actually use the order to fix it. So with the order, we can always ensure the functions, the order of the function can be generated in any specific way that we want. So same thing for the ENI, because the ENI MAC needs to be added in the front, while the actual ENI table is actually added in the end of the function list. So that one is the same thing. It's a little bit like counterintuitive of how the SI API gets defined, but with the order we can use in any way we want. If we change the definition, like the order of the definition in the P4 code, you won't change the actual API we generated. So that is the API compatibility. And last would be like more feature support, for example, list and range. We actually can now generate the correct SI header files along with libsci for BMV2, so we can actually convert the parameters into whatever the BMV2 support currently. Of course, a simplified implementation is not perfect. For example, in the list, we'll just take the first element. The range, BMV2 doesn't really support a range, so we will take the mean instead of the range as an exact match. But at least right now, the header files works, and we actually have a libsci can do a simple job. And the second one would be like a user counter to generate the attribute. This is what I mentioned. Like here, we actually have a way to do this correlation from the annotation as well as the P4IR, so we can actually generate the correct API headers with certainty. So I also did some of the cleanup works, ignore some files or whatever. So that is just like, yeah. And last one is actually the future works that we haven't done yet. For example, we generate the counters. Right now, you can generate the counter ID, but it doesn't support generating stats as a get stats semantics in the SI API. So this one, currently, we are actually working at it because right now the SI doesn't really support stats extension. So there will be a SI changes first introduced in the SI. Then we can take the latest SI to the dash and then enable the stats support. The second one is to better leverage the counters and registers. For example, we actually have a counters that is not not actually the packet count or byte count. It is whatever the the number of, for example, number of flows we created. Well, it's not a regular like the data bus counter, but it is indeed a type of counter. So those counters can be generated to the stats, but we will need a way to actually see how to support those counters if any of them exist in the P4 pipeline. The last one would be the SI events. So this one is like, for example, we actually have in the SI we actually have those events. Those events can be like generated as well, as long as we have a P4 definition, because it is a struct. So basically, as long as we have the struct defined, and we have a way to get the struct out from either P4 runtime or the IR, which is both of them are like backend independent. So those things can be like used to generate the side events. That would be like something really nice to have. There could be more, so this will be an incomplete list. Really, just like when doing the development along the line, depends on what we found. But yeah, this is all the changes that I made recently to the side API generator. So hopefully this would be helpful to our future works for any feature that we add in the future. Okay, so that is basically everything. Yeah, thanks a lot, everyone. Okay, I'm muting myself. I'm going to stop sharing.
Did you want time for some Q&A? Is there any Q&A for this improvement, guys? Yeah.
Yeah, then it would be great.
Okay.
Just see if
I know
any questions.
People pretty involved in P4 and P, there's, of course, Andy, Marian, Bud, Chris. Yeah. So if you have any questions.
Great job, Riff. That was very helpful. You've really taken this forward in a great way. Really
Thanks a lot, Chris.
The whole approach. One thing I wanted to add on the P4 side is I noticed you're using P4 intermediate representation because P4 info doesn't have everything you need, and that seems like a great idea. Is there anything in P4 info, or if there's anything in P4 info or the language itself that you think could be improved someday to benefit these kinds of use cases? You're always welcome to attend those working groups and put things out on the table for people to discuss. It's a very open community, and if you think there's something, or if you have a question about it, please feel free to participate. I'm on a working group, the P4 API working group, which defines the P4 runtime spec, and there's others in this meeting that attend various working groups too. So it's an open community. Please feel free to join.
That would be awesome. Yeah, thanks a lot, Chris.
Anyone else have questions? Okay.
I have a browser open. If any questions, let me know. I can share the screen. I can point to whichever. So
Okay, great. Thanks, Riff.
Okay.
Thanks.
Yep.
Awesome. I'll go ahead and steal the share back. So just taking a few notes there. Mircea, are you on the call? I was wondering if I could ask you about the one in the chat window. 455.
Yes, I'm here.
Hi. Is there anything I needed to do with this one, the 455? I think the last changes were, can you make a change here into the -SONiC HLD?
No, do not merge it. I think I made a mistake.
Okay.
Actually, when I tried it, I think it works. Let me give it one more try and then I'll cancel it.
Okay. Okay, awesome. Thank you. And then, Marian, did I need to do anything with this refactor tunnels, PR?
No, there are comments. I need to address them.
Oh, okay, you're going to do that. Okay, awesome. And okay, great. So I'm just going to look at the issues real quick. And on this. Looks like I have a few issues I need to look through. I'll try and make some time later this week. So I guess that's it for today, unless Andy or Bud, did you guys have anything, or Naren?
No updates or questions here today.
Nothing? Okay.
Yeah,
all right.
For me.
Okay. All right. Well, I want to thank you guys for coming. Oh, I forgot Chi and Sushant. You guys good? or do you have any Q&A?
No, we're good. Thank you.
Okay, all right. All right, thanks. Then I guess we'll stop at 10:39 and I'll publish the notes a little more in a timely fashion. And I hope you have a good day.
Thanks a lot, Christina.
Thanks, everyone. Okay, bye-bye.
Thanks a lot, everyone. Thank you.
Bye-bye.